So the sum of the 3 floor lengths is 168 feet. Strange looking house. What's the length of each floor? Well, since this side is cut 12 and 12, that means that this length, the top floor, is a mid-segment of this the middle triangle, we'll say. So that means the bottom side of the middle triangle is double. Mid-segment is half the base. Now if you look at the largest triangle on the middle triangle is formed with a mid-segment, because 12 plus 12 is 24, so it's 24 above, 24 below, which means that the base is going to be twice as large as the middle floor. So that's going to be 4x. So x plus 2x plus 4x, that's 7x. That's all 3 floors added up is 7x, and that equals 168. So divide by 7, you get x equals 24 feet. That's the top floor. The middle floor is double that. So that will be 48 feet. 2 times 24. And then the bottom floor, you can either just double it again, or you could take the original top floor times 4, and you get 96 feet. So there's the 3 floor lengths. And you can check it out. Yes, they do add to be 168. This question uses that same theorem, that the mid-segment is half the length of the base, which means to equal the base, you have to multiply the mid-segment times 2. So that's 2 times 3x plus 1. Then they'll be equal. You have to double the mid-segment to equal the base. So 6x plus 2 equals 7x minus 7. Subtract the 6x, you get x. Add the 7, you get 9. X equals 9. So here we've got a proof, trying to prove that angle ACB is congruent to angle DEB. So these angles down here at the bottom. We are told that CB to EB and AB to DB. So just putting these little squiggles on there to identify which one goes with which, because the sides are proportional, which is going to lead to some similarity in the triangle. So we are told CB to EB equals AB over DB. Always start with a given. Now, much like when we were proving triangles congruent, you can draw information from the picture, like vertical angles. The angles are congruent because they are vertical angles. So that's angle ABC and DBE. So now we have two sides are proportional with the angle in between. So the triangles are not congruent, they are similar. Because of side, angle, side, two sides with the angle in between. Side angle side similarity. But since the triangles are similar, that means all of their angles are congruent. All of their corresponding angles, ACB and DEB, those are corresponding angles. When we were dealing with congruent triangles, we said CPCTC. It's kind of the same idea. You just have to write something along the lines of them being corresponding. And that'll get the point across. They're corresponding angles in similar triangles. Given the points x and y, find the coordinates that partition it into a 2-to-3 ratio. So when you're doing this, the formula way of doing it is you have to take the first number in the ratio with the second point. So you're going to multiply 2 times -7, 2 times 7, and you take the second number in the ratio with the first point. 3 times -2 and 3 times 5. So that's pretty much like the midpoint formula where you add the two numbers together and divide. But since we're dividing it into a 2-to-3 ratio, that's 5 parts. So we have to divide by 5. So we add those numbers together, -6 with the other x coordinate, -14, divided by 5. 15 plus the other y coordinate, 14, divided by 5. That's -20 over 5 and 29 over 5. You can simplify that to -4. You can either leave that 29 over 5, or you can change it to a decimal, which would be 5.8. The image projected on the smartboard is 1 meter wide. If the same image on the computer is 10 millimeters, what is the scale factor of the projection? So we're just figuring out what the ratio is, what the scale factor is to get from 10 millimeters to 1 meter. So we take the length of the projection first, the length of the image is 1 meter. We divide it by the pre-image, which is 10 millimeters. Now the problem with this is meters and millimeters are not the same unit. They need to be the exact same. So we need to change 1 meter to 1,000 millimeters. Likewise, 2 meters would be 2,000, 8 meters would be 8,000. It's 1,000 millimeters in a meter. And then divided by 10 millimeters. Since they're the same, we can do this. 1,000 divided by 10 is 100. So our scale factor is 100. Scale factor is the length of the projection over the length of the original. The length of the image over the length of the pre-image. So we're going to fill in the blanks here for the sequence of similarity transformations to explain why triangle ABC down here is similar to triangle XYZ. So we're told we've got a rotation going on. So to get from down here in quadrant 3 up to quadrant 1, that will be a 180-degree rotation. Either way, you could have gone counterclockwise also. It's still 180 degrees. And then if we do that, let's trace where our points would be. So the rule for a 180-degree rotation about the origin is that the sign changes on the x and the y. xy goes to negative x, negative y for every coordinate. So A, which is over here at negative 11, negative 6, is going to rotate around to positive 11, positive 6. Positive 11, positive 6. Likewise, you take point C, which is over here at negative 11, negative 4. It's going to go to positive 11, positive 4. Positive 11, positive 4. That would be C prime. And we can take B, which is at negative 6, negative 6. That's going to go to positive 6, positive 6. Then we have to dilate it by a scale factor of blank. So right now, currently, AB has a length of 1, 2, 3, 4, 5, and it needs to have a length of 6, 7, 8, 9, 10. We have to get from 5 to 10. Likewise, we have to go from 2 to 4. So you double it, you multiply by 2. And then anytime that you have a point that does not move, that's your center. If you didn't know what the center was, then you'd have to draw the lines that would connect the image to the pre-image, and that would show you where the center is, which we'll see in a second. But this point remains unchanged, so it's going to be centered at, you could say A, you could say A prime, or you could say X, it doesn't really matter. You could also say the right angle, since that's a right angle there. You could also say the right angle. Or you could name that point, which is 11, 6. There's lots of ways that you could word that. I should say A prime. So here's the problem I was just referring to, where you are trying to find the center of dilation. Since you know all the image and pre-image points, you just connect them. So you draw the line from B to B prime, from C to C prime, and from A to A prime, or A prime to A, depending on which way you want to draw it. You just draw the lines that pass through them, and all of those lines will intersect at one point. That point is the center. Here they all intersect at that point. So the center is 6, negative 4. So now we're going to look at another directed line segment split into a ratio, but this time we need to figure out the ratio. So you know all 3 points. Go ahead and plot them. -9, 8. Three, -10. And then C is -5, 2. When you draw the line connecting them, it should all be collinear. They're all on the same line. You just need to figure out what the slope is of that line, and then count how many times it's done to get from A to C and from C to B, and that will be your ratio. So here, if you count out the slope, it appears like it goes down. Here's a good point we can use. Down 3/2. So repeat that. Down 3/2. Down 3/2. Down 3/2. Down 3/2. Down 3/2. So you just need to count how many times the slope was done on the left side. So that's 1, 2. And how many times it was done on the right side. 1, 2, 3, 4. So that's a 2:4 ratio, which isn't really proper. Now, when you're writing your ratio, make sure, since it says A first, you start with A. There's 2 on the side of A and 4 on the side of B. But 2:4 is not really a proper ratio. You need to reduce that as if it were a fraction, because ratios are fractions. So that's a 1:2 ratio. Let's take a look at another one of those. Plot the points, -9, -8. That's A. B is 6, -3. And then C is at 0, -5. So when you draw the line, they should be collinear. Figure out the slope of that line. Appears like it goes up 1/3. Up 1/3. Up 1/3. And you just count how many times it was done on each side. Starting with A, 1, 2, 3. And then on the other side, 1, 2. So that's a 3:2 ratio.